Hello, and welcome to our series on data science. Over the past decades, data has become an important asset, not only for the competitiveness and growth of businesses, but also for our own professional lives. Various terminologies emerged, like big data, data mining, knowledge discovery in databases, also known as KDD, machine learning, data analysis, and data analytics. Also, new careers emerged, allowing professionals to develop different skills from soft to hard and apply them in the many data-related jobs that appeared and are available in the market. All that promoted the appearance of specific courses and programs covering the topics necessary to train professionals for these areas. This series covers all these topics: the terminologies in data science, the data science workflow, the main careers, and the main courses available. The approach presented here is technical, and I will mix some background from the literature with my own interpretation of the areas, such that you can learn where to search for information and build your own understanding of such an extraordinary field. In this first part of the series, I am going to present you the main concepts of big data, data mining, knowledge discovery in databases, or KDD, machine learning, data analytics, and data analysis. I will present a summary of the main features of each terminology and a trade-off among them. So, welcome and enjoy this series. Here we are going to see the many terminologies that we have in data science. We'll start with big data, then we'll go to data mining, knowledge discovery in databases, machine learning, data analytics, and data analysis. In the definition proposed by Emmanuel and Stanier in their paper called Defining Big Data, they emphasize the data environment, that is, all the infrastructure necessary to host and process the data, affirming that this architecture has to be scalable. And they also included the analytical infrastructure, which are basically composed of the software necessary to analyze the data and also their applications. And then they detach the high velocity, volume, and variety of this data, bringing together the three main components of what has been known as the 3 V's of big data. In the definition proposed by Sagiroglu and Sinank in their paper called Big Data, a Review, they focus big data on the massive volumes of data, and then they call big data analytics as the process necessary to extract hidden patterns out of this data. So it's very common for us to see in the literature the concept of big data related only with the 3 V's. But the 3 V's basically compose the raw material for big data. In my perspective, big data is more than the data itself. It also involves the hardware infrastructure necessary to store and process all this data, and also the software infrastructure necessary to analyze and to extract value out of this data. All the modeling and analytics is also part of big data. Well, in summary, I would say that big data is the area that deals with the storage, processing, and analysis of large data sets with specific characteristics. Here I'm taking the 3 main V's of big data, which are velocity, variety, and volume, but I am also considering other V's that have been added with time, like the veracity of the data, the value, the variability, and a few other V's that you can find in the literature. While the concept of big data emerged and gained traction in between 2005 and 2010, another concept in the field called data mining is much older. It emerged and gained traction by the mid-1990s, so I'd say around 10 to 15 years prior to traction of big data. And data mining is more focused on the process of discovering patterns in data. So it talks less about the characteristics of the data themselves and focus much more on the process. And it's expected to be either automatic or semi-automatic, and the patterns that are extracted from the data are expected to be meaningful in the sense that they cannot be trivial. They cannot be patterns that you can find by simply looking at the data manually. So you need a sort of technique or a sort of method that allows you to extract more from the data than simply doing a query or applying some specific filters to your data. And this concept comes from the Wheaton book. This is one of the most important books in the field of data mining. Let's take now the concept of another very important book in the field by Han and collaborators called Data Mining Concepts and Techniques. They define data mining as the process of discovering interesting patterns and knowledge from large amounts of data. Here they also add the information that the data set has to be large, but note that what is a large data set? This is a vague concept and it may vary depending on the infrastructure that you have. So the most important thing from these two definitions here is that data mining is focused on extracting knowledge from data. Another concept that is also from the 90s is the concept of knowledge discovery in databases. Actually, based on the work of Piatek Shapiro, published in 1991, this terminology, knowledge discovery in databases, this was coined at the first KDD workshop back in 1989, so in the end of the 80s. And KDD refers to the process of discovering useful knowledge from data. If we look at it and if we compare with the concepts of data mining that we presented in the previous slide, we're going to see that they are pretty much talking about the same thing. However, if you look at KDD in more details, you note that KDD sees data mining as one particular step in the whole process. Let's have a look at the KDD process or the KDD workflow. I'm going to show you two different versions from different authors, and we are going to note that they are very similar with slight variations. This is important for us to realize that sometimes the literature does not converge to a single nomenclature or to a single process flow for the methods that we are dealing with here. And this is because these are slightly young areas of research with 30 or no more than 40 years of research. So things are still maturing and getting positioned within the whole scientific literature. In this first version of the KDD workflow, we can see 5 main steps, including selection, pre-processing, transformation, data mining, and evaluation. The first step is you start with your data, then you select some data that's going to be called your target data, which is from among all data that you have, which one you're going to use in your KDD process. Then you prepare this data for analysis. So we have the pre-processed data here. You apply some transformation techniques. Then you have the data mining itself that is going to allow you to go from the transformed data or the pre-processed data into patterns. And then after you evaluate and you validate everything that you did before, you have what is known as the knowledge, right? So you go from data to knowledge. This second version is slightly simpler than the other one because it basically integrates 2 steps in a single step here. From the data that you have, you do some cleaning and integration. This is going to generate your data warehouse. From this data warehouse, you're going to select and apply some transformation. Then you have the pre-processed data. Then you do the data mining, you extract patterns, you do evaluation and presentation and validation, and this results in the knowledge. Note that both these workflows, they consider data mining as one step of the KDD process. However, if you look at the literature, in many cases, you see that the terminology data mining also incorporates all these other steps that we have here. Both cases, this case that I'm presenting here, which is version 2, and also the case that we are presenting here in version 1. And this means that these terminologies, data mining and KDD, are usually used interchangeably. Another concept that is very common and important in the literature is the concept of machine learning. Machine learning has also been around for longer than big data. If you look at the concept of machine learning, we can basically find 2 different approaches for it in the literature. One of them is similar to the proposal of Tom Mitchell in his pioneer book on machine learning, published in 1997, which is the design of computer programs that automatically improve with experience. That is, computer programs that learn from experience. And in another approach, such as the one presented here in the work by Hoyen, we have the machine learning as an approach to learn from data, right? So this is a more generic perspective of machine learning, and this is a perspective that is more focused on the use of computer techniques to extract knowledge from data. And if we are going to contrast this perspective of machine learning as an approach to learn from data, this is very similar to data mining. One difference is that machine learning is usually more focused on the algorithms themselves and their applications to the data, whilst data mining focused more on the process from data preparation to the application of the machine learning algorithms. Another important terminology that we have is the one associated with data analytics. Data analytics can be seen as a multidisciplinary area that works quantitatively and qualitatively with data, with the goal of extracting conclusions or insights from the data, and also to extract and prove hypotheses about the data, aiming at decision-making and action. With this perspective, we have data analytics as an area that incorporates data mining, KDD, machine learning, and also data analysis. Data analysis, by contrast, is more focused on the characterization, summarization, explanation, and visualization from data. Usually, when we talk about data analysis, we are talking about the processes that do not involve inference, that do not involve generalization. Right? So one way of distinguishing between machine learning and data analysis and data analytics is that machine learning, the application of most algorithms in machine learning, is focused on inferring something or building a model capable of inferring something from your data. And this means that you want to extrapolate the information that is available in your data so that you can, for example, make predictions, you can find clusters within the data set, you can find associations among variables, whilst in data analysis, you just want to characterize and you want to summarize and visualize the data. It's usually considered a step that comes before this step of data analytics or this step of data mining that we have in the whole process. To conclude, I'm going to make a parallel among the 6 different terminologies, considering if they include the step of preprocessing, the extraction of insights from data, the visualization of data, the design, the planning design of dashboards, the inference, which is the extrapolation from the knowledge that you have available in the data, the focus on the infrastructure necessary to store and process the data, and finally, if it is focused on large amounts of data or not. And based on these characteristics, we can see that big data incorporates all of them with the exception of dashboarding. Usually, when we are doing big data, we are not really concerned with building dashboards to visualize data, right? Of course, that your project can involve everything, including dashboards, but this would mean that your project involves not only big data, but also data analysis, because data analysis is one of the main techniques that is concerned with the design of dashboards. And if we consider KDD as the whole process of analyzing data, including data mining and data analysis, the dashboarding stage will also be part of the KDD process. When looking at data mining, we see everything as well with the exception of dashboarding and the infrastructure. When we talk about data mining, KDD, machine learning, data analysis, data analytics, of course, we have to be concerned with the infrastructure in which we are going to store and process this data, but these are usually not considered part of these areas specifically, right? They are much more in the area of big data. Finally, looking at data analysis here, we can see that it is the only area that is not concerned with the inference, that is not concerned with the generalization capability of the models. And here, when I mention data analysis here, I am thinking more specifically about exploratory data analysis, right? But of course, you can use and you can find in the literature the use of all these techniques interchangeably, right? So you can talk about big data for a project that would be a more machine learning project. You can talk about this project as a KDD or a data mining project, and so on and so forth, right? So the frontiers among these areas are a bit fuzzy, And the way that these terminologies are used in the literature also varies a little bit, right? So the goal of this part of the series was to bring some light for you of what are these terminologies and how they can be used so that you understand better the difference among them. Thank you for watching and see you in our next part of the series.